High five.
Hey, hi everyone.
Yeah. So let me introduce and we'll give you on that.
Sure. Am I audible
Yeah.
to you?
Complete. Yeah.
Oh, perfect.
We'll
If you
record.
want to wait for a couple of minutes, that's fine too. If you're
Yeah.
waiting for few folks.
Thank you for joining too early and that place.
It's fine. While we are waiting to start, are all of you guys from Gandhinagar?
Yeah. So mostly people are from Gandhinagar, Ahmedabad, from majorly around Gujarat.
Okay, nice. I am also a Gujarati.
Nice. From which place
My
you were?
husband is so I am from Mumbai. My husband is from Ahmedabad. So
Nice.
yeah, nice. You can
Nice.
ask questions in Gujarati if all the audience is Gujarati.
Yeah. So it will be a back station for your like old local community.
Oh, yes.
Nice. Yeah. Let me start. So
Sure.
welcome everyone to our next session of the KCNA Bootcamp. We have completed two sessions previously, and this one is third. And that's around cloud native architecture, where we are going on auto scaling, serverless, cloud governance, different part of thing. And yeah, here is your host Neil Shah, one of the organizers of CNCG Gandhinagar, and we are happy to host you over here. And we have amazing expert Payal over here who have like joined in early morning around 7 at their place. So yeah, welcome her and yeah, stage is yours.
Yeah,
You can go ahead.
sure. Thanks for having me, and good evening to all you folks. And morning if anyone is joining from States. Yeah, so I I I'm based of Seattle. I work in Oracle Cloud. I'm a principal engineer over there. Am I work in a distributed DevOps deployment service. It's a cloud facing service where we use Kubernetes extensively. So, today we are going to talk about auto scaling part of it. And I hope I don't bore you guys. But at any point, if you have any questions, feel free to stop me and ask. I will go ahead and share my screen. Is my screen visible to everyone?
Yes, yes, perfect.
Okay, yeah. So, like what I was saying, we are going to talk about how auto scaling works and how cloud providers typically use it, and what are some of the challenges that we face. Yeah. The first topic being, why do we need auto scaling? What are the benefits of it, and what are the different types of auto scaling which is available in Kubernetes? Um, as you could imagine, I hope if I hope anyone would have tried and tinkered around what auto scaling is in Kubernetes. But just to give a very high level overview, when the demand surges, you don't want any manual intervention. You want your Kubernetes to take care of it without waking you up. For example, in distributed systems, it's quite common for all of us to be on call, right? So, for example, if we are having a peak traffic at any point of time, we don't want our on calls to wake up at 2 a.m. or 3 a.m. in the night just to meet that traffic demand. So auto scaling comes in picture over there. We will go into the details in next couple of slides. And as you could imagine, there would be a lot of benefits when it comes to the performance and cost optimizations as well. We cloud providers are getting increasingly savvy about their costs and where they are spending. So we do not want to waste our compute because it's expensive, especially when it comes to infrastructure level of services like AWS or Google Cloud or Oracle Cloud for that matter. So we want to squeeze out every single ounce of CPU that we could, and we don't want to overutilize it at all. And similarly, we don't want to underutilize, because that will result in sluggishness from on the user side, on the customer side. We really don't want. We want customers to have the best world class experience when they come to our platform, especially when it is such a competitive landscape, right? And then we'll go over what are the different type of auto scalings that are available in Kubernetes. We are going to go over very high level basics and on where you could use it. Yeah. So like few challenges on why we need auto scaling. Like traffic is unpredictable. For example, let's say you have Diwali coming over and you would expect Blinkit to have so much of traffic during that time. Or for example, you are having an IPL match on Hotstar. Traffic would surge, especially when it's India Pakistan, right? So during those time, you really want all your applications to be running up and super smooth. Your pods or containers, if you happen to use Kubernetes, should be started. No cold start times would be acceptable at this point, because even a 10-second lag on your video streaming would you could imagine it would be not a very good experience, right? Manual scaling is usually more on the reactive side. It is slow. It wouldn't be as super smooth. Like I was saying earlier, over provisioning will lead to wastage of money. We don't want that. But when it comes to compute, when it comes to memory, when it comes to your network, any of those, right? And similarly, under provisioning, if you were to give little less CPU to any of your compute instance, it will result in the slowness. The processes wouldn't finish in time, or it will take longer than expected. The latency would increase, and we really don't want that response latency to increase. For example, if I'm posting a Reddit thread, you want it to be super fast and come up, right? You don't want that 30-second lag that is coming in between. It would be frustrating to the users. Kubernetes, for this purpose, gives us like three different types of auto scaling. There is horizontal pod autoscaler, there is vertical pod autoscaler, and there is cluster autoscaler as well. I'll take a stop over here and see if you guys have any questions. Feel free to post in the chat too. Okay, perfect. Yes, e-commerce on Black Friday is a perfect example. We all our platforms are super choked during that time. Uh, So now coming to different types of what is a horizontal pod autoscaler. It basically means, for anyone who is not aware of pod, it is just a container. It is the smallest execution unit in the cloud native ecosystem. When it comes to horizontal pod autoscaler, you are scaling horizontally, which means you are spinning more pods or you are creating more replicas for your applications, right? For example, if there is a web server that is running, you might want to have three replicas of it, because if any one crashes, you would have other two to service your traffic. What is vertical pod autoscaler? We'll go in detail into all of these, but vertical pod autoscaler is you are trying to make your resources that are allocated to the pod increase. For example, if CPU, we typically in Kubernetes we tend to give it like in 100 milli CPU or 250 milli CPU. Here you would want to increase it to like one CPU, which is like a whole CPU. Or memory, you would want to increase memory from 125 to 256, or the other way around. If you want to decrease it, that also vertical pod autoscaler would help you over there. And last comes the cluster autoscaler. In cluster autoscaler is basically when you want to increase the nodes, your nodes in the node pool, so that if we are seeing super more demand and we want to add more compute to it, we will add a different node altogether, because at that time when you see there are pods that are not being able to schedule, at that time cluster autoscaler comes in picture, and that is one of the most expensive ones. So that would be our last resort. Yeah. So these are there is one other one also that is coming in picture and emerging right now, known as KEDA, but I'm leaving it out of discussion right now because these are the three main primary ones that we typically use on a day-to-day basis. Okay. Now diving over how a horizontal pod autoscaler works, right? As we discussed, horizontal pod autoscaler would scale your number of pods based on CPU, memory, custom, and any other custom matrix. So, in order for horizontal pod autoscaler to work, you need to have Kubernetes matrix servers turned on. It's an optional thing right now, but on your Kubernetes cluster, you would want that matrix servers to be turned on. Now, I'll tell you why you need to turn it on, right? So the Kubernetes controller on the back end will keep on measuring the matrix every 15 seconds or so. The period of the period of polling is all can also be tuned by you by scheduling by configuring a sync period or something. But every 15 seconds, using Kubernetes matrix server, it will try to extract the matrix and see what is the usage of the CPU or what is the usage of memory. Let's take a brief example of CPU utilization. In this case, the target CPU utilization is 50%, right? So it will keep on monitoring, okay, is my pod consuming 50% of its allocated CPU or more? If it is consuming more at any point of time, then it will create one more replica, and using min replica and max replica, you will decide how many pods you want to scale or scale up or scale down. So in this case, it has the luxury to go up to like 10 pods. But if it sees that, okay, the utilization is not 50, it is less than 50, then it will start scaling down. So this you would want to use horizontal pod scaler, especially when it comes to web application during high traffic, like the scenarios that we discussed. It would be pretty useful over there. So a typical life cycle would be it keeps on monitoring the matrix based on the sync period you decide. It will evaluate your needs. If scaling, it will look for all these parameters to understand, okay, do I need to scale pods? If yes, it will go ahead and scale the pods, and it will try to maintain the performance as you have crafted in your horizontal pod autoscaler. Okay, so the way you craft this autopod scaler is using a YAML file, or there is a Kubernetes command to kubectl autoscale command that you could use. I have given a sample YAML file that you could use to scale it. Here you will tell which type of deployment. For example, in this case, I would want to scale my web app application. The number of replicas minimum is 2, and the maximum I would want to scale it go up to 10. And based on which matrix I'm going to decide on whether I want to scale or I don't want to scale is here it is CPU. But you with horizontal pod autoscaler, you can give memory also. And there are other metrics also that you could use. For example, your network packets. Like if you are, what is the number of packets per second. If you are expecting certain amount of traffic, HPA gives you the luxury to tune those custom metrics. How do you define those custom matrices? You could use a controller for that, an adapter. Prometheus is one of the very famous one that all the cloud providers typically use, which helps you gather matrix to the tiniest details. I'll stop over here and see if anyone has any other questions. You guys are very quiet.
So I think so what are the mean and max replicas? You can just elaborate like in YAML
Sure.
file.
So min and max replicas are the number of pods running your application. For example, if you are running an Nginx web server, right? So you will min replicas by minimum 2 replicas means your 2 containers are running Nginx web server. But if your traffic is scaling and you are seeing that you're crossing that CPU utilization of 50, you have the luxury of running all the way up to 10. So you will have 10 containers running your Nginx web server in this case. But that has to be configured by the user or the administrator in this case. Cool. It is all, yeah. So now, coming to the vertical pod autoscaler, right? The vertical pod autoscaler is very resource driven, by meaning it is very constrained as compared to horizontal pod autoscaler. Horizontal pod autoscaler allows you to uh, monitor like different metrics, CPU, memory, network. But with vertical pod autoscaler, it allows you to just tune based on your memory and CPU. For example, in this case, just based on the picture, like you are seeing that your memory consumption is increasing beyond 64 megabit, and you would want to go up till 128. So you're typically increasing the resources which are already allocated to the pod. Like you're going similarly for the CPU also, you can go and increase the CPU. Here it is 100 milli CPU, like but you can go up to like 1 CPU to 250 milli CPU. Yeah, so you are giving more resources to one particular pod. In we in Typically in distributed systems, we don't allocate one CPU. We always try to give as little possible. Like you can start with 100 M and max allowed is 1. So if, for example, if your workload is using just 100 M, you don't need to give one, right? So that means you can schedule more and more number of pods on that particular node and squeeze out more compute and memory just to be very cost effective. Yeah. Uh, so there are different policies with vertical pod autoscaler. So yeah, this is if you want to craft a vertical pod autoscaler, you would have to specify the kind. This decides the Kubernetes resource kind, which is vertical pod autoscaler. What type of application should it scale? Here is the deployment application. What is the type of update policy? There are 3 policies that is we'll go on this in the next slide. And what are the control resources? Here I have by default it is CPU and memory, but you can also choose to have just one CPU or memory. And then what is the minimum allowed CPU that you want to give when the container starts, and how much till it can consume during during the lifespan. Yeah. So the 3 update modes of the VPA are like off, initial, and auto. Like the personality of it is like when it is off, it is like I have my opinions. I'm going to keep it to myself. It just gives a recommendation. It doesn't enforce it in any way. So, but you can view those using kubectl describe VPA. You can typically use this when you are testing it before you are going out in the production on what could be the best scenario and what could be the possible size I should be using. The second is initial, which will, hey, I will come and fix you up, but I will do it only once. That is when you are starting your pod for this first time, or when you are creating your application for the first time. It just comes into picture at the first time and then goes away. These are typically when you have like fairly stable workload. Your database traffic, for example, is super stable. You're not expecting any spike or something. At that time, you would want to use this setting. And the last one is auto one, which means it keeps on coming into picture. It is like yeah, it will keep on changing and fluctuating your CPU and memory. You should do when your workload is spiky and when it is more dynamic in nature. At that time, you would want to use VPA, but it does come with its own challenges also, which will go in the next slide. So this is how it is. How, for example, let's say we have decided to resize the memory. How would we resize the memory is the VPA would recommend new resources. Then the pod update gets triggered. Like, okay, we are going to allocate more memory to this particular pod. But what happens we right now we are having a pod, let's say of 128 megabyte, and the new size that VPA recommends is 256 megabyte. Then the pod, which is with 128 megabytes, has to be stopped. So the traffic that it is servicing needs to be stopped. It has to be evicted, and then the new pod will come into picture. So you could expect that, for example, if your Blinkit is just running on this one particular pod and that pod goes away and the new pod comes in picture, the time to transition would at least be couple of seconds, right? So at that point, it's a blackout period for you. So you want, at that point, you want to make sure that at least you have like 3 to 4 replicas to service your traffic. Yeah, so those things you have to keep in mind. So once the pod gets evicted, the new pod gets created, and the new pod will come with the new settings. In this case, it would be 256 megabits. Yeah. Uh, so if there are two types of applications that are typically around. One is stateless ones and stateful ones. The stateless meaning, like database is not a stateless application, right? It's a stateful application. By that, what I mean is you would want to persist your data somewhere. You cannot, wouldn't be just like a clean wipe, but all your applications where, for example, even a Redis in-memory cache, that is also a stateful application. Like you cannot afford to lose data. All those applications are typically known as a stateful application, right? So then how do you use VPA for stateless versus stateful? The memory management of it. For example, it's a stateless application. You can almost think of it like a dry erase board, or just it has a memory of like a goldfish. It keeps on getting wiped every single time, clean every single time, right? But the stateful application is like you are having a diary. You want to keep a track of everything. Nothing is forgotten. If you want to save something, you would have to persist it yourself. VPA doesn't take care of it, right? Then you would have to take backup of it. Like the adjustment when it comes to resizing. We just went over the life cycle of how the memory resizing would work. So in case of the stateless one, even if you resize, it wouldn't matter. That's fine, right? Because it doesn't have to really persist a state. But for stateful one, you would have to pack up your suitcase, don't spill anything. Keep in mind that resizing will affect your application. Then how do you protect it? What are the steps it needs to take? The, like a pod restart. Like a pod restart in this case would also affect a stateful application more than a stateless one. Keep persistent storage in mind. Graceful shutdown. If whenever a stateful application goes down, you want to make sure that all the database records that you would want to keep are already written onto your persistent storage before it is shut down, rather than it just shuts down and you don't have backup. In this case, you would lose your data, as you could imagine. Yeah, so that was the vertical pod autoscaler. Now we come to the most expensive one, the cluster autoscaler, which we use very sparingly. We At least in the when it comes to cloud providers, because it gets very expensive to add a whole new node pool, and we typically have to go through multiple level of approvals to if we have to get a whole new node pool, because it's expensive. Primarily, it is basically your the way it works on the back end is, let's say your entire cluster has just 4 CPUs for it, and you have pods or you have containers already scheduled on your Kubernetes cluster which are consuming all the 4 CPUs. But now I need more CPUs to cater to the new traffic. In that case, I would have to add a whole new node. But then if I'm not adding, how does cluster autoscaler determine in this case? So it will in this case, if I will keep on scheduling more containers to my existing cluster, all of them, all the pods will remain in the scheduled state or in a pending state. So the cluster autoscaler keeps on detecting, hey, how many pods are not yet scheduled, or how many pods are still in the queue. If the queue keeps on getting longer and longer, after a certain point of time, it decides to scale up. That, hey, looks like my traffic is super high at this point, and I would have to add a new node to service all this traffic. So it will go and add a new node. Similarly, it will keep on monitoring the node utilization. And if it decides, hey, it looks like now I don't need that many new nodes, we can scale down, then it will go ahead and start evicting the nodes. But yes, before you evict the nodes, right? For example, if you need to drain the nodes. What do I mean by draining the nodes? For example, I have 3 nodes. I want to My node utilization is such that 2 nodes would suffice. But what if there are pods or applications running all on my third node? How do I do that? Then you would want to drain that node, make sure that all those pods are migrated to the 2 nodes before you start off the drain. You at no point you want a brownout or a blackout. Yep. So yeah, you typically use cluster autoscale by specifying the min nodes and the maximum number of nodes. Yeah, it works with all major cloud providers out there. But the main metric on which cluster autoscaler works is your unscheduled pods. You can detect this using Grafana. So Grafana is a very friendly web-based tool that you could use to understand what is the traffic coming in, what's the traffic going out, understand the granularity of each and every matrix. What is my network incoming traffic? What is my database traffic? What is my database connection pool looking like? So yeah, Grafana and Prometheus are the most prominent ones. Yeah. So, what are some of the best practices you could use for Kubernetes autoscaling? Don't rely on one autoscaler. Try to combine at least one or two, depending upon the use case. Like for scaling web traffic, we typically use an HPA and cluster autoscaler together. Like fine, and the second one is fine tune your CPU and memory depending upon your workload. For example, if I'm using a machine learning training workload, it will, and if I'm just using CPU for my training, it would be more CPU intensive. So I would want to use fine tune my CPU accordingly. But an LLM model will consume lot more CPU than a rather tree-based decision model like XGBoost. So you want to be very mindful of which workload you are using and how much CPU it would probably need. Monitor your auto scaling behavior first using one of the tools that we discussed. Test it in your test environments or any dev environments before it goes out to the production. Yeah. So auto scaling isn't magic. It has a lot of issues too, and we need to be mindful of it while we are crafting our Kubernetes configuration. For example, cold starts can be costly. Like every time a pod restart, even if you have pods that have started quickly, for it to start servicing your traffic, it will at least take 5 to 6 seconds and sometimes even more. It can take even up to 30 seconds, right? So then how do you mitigate this 30 seconds? You don't want your users to wait for this 30 seconds. Like if you post an Instagram picture and it is taking 30 seconds to come up, users will be like, hey, what is going on? Where's that picture, right? So you would want all your pods to have started warmed up, have started servicing the traffic. So that part comes on to you, right? How are you managing that? Slow pod or node startup, for example, a cluster autoscaler decides I want to add a new node on an Amazon EC2 instance, which is one of the very popular EC2 instances. Even if you start up a node like that and try to pull it, it will take a good 3 to 5 minutes for it to start completely, right? Even for a pod, horizontal pod autoscaler decides, hey, I want to start a new pod. It takes at least good few milliseconds for the pod to start. Milliseconds for us, it looks like a very small time, but when it comes to infrastructure, it can be super huge. Then improper matrix, for example, if I'm having a chat application, let's say a WhatsApp, right? Or what, and if I'm trying to have an horizontal pod autoscaler on CPU for a chat application, it would be totally inappropriate. A chat application is more network driven, how many connections it is going to pull, right? The CPU it consumes is very low, right? So you're not meeting the needs. You have to assess what your application needs, and depending on that, you have to craft your autoscaler on which custom matrix it needs to depend on. Then trashing. If your auto scaling configurations are too sensitive, like you keep on scaling every 2 seconds up and down, then you would hurt yourself more than benefit from auto scaling, right? The other one is dependency bottlenecks. If you work in any cloud provider service, you typically depend on certain downstream services, right? For example, one of the services that we use is database services. Let's say I have scaled my application to use lot of horizontal pod autoscalers, start servicing lot of traffic, but I'm rate limited by the number of connections by my downstream service, which means I can open up only 100 connections. So if there is a gap between the two, I want my database to service 1,000 connections and not just 100. So you have to make sure that all the downstream services that you are using are also sufficing your demand and tuned with the auto scaling configurations that you have decided. And yes, if you don't have any insights into the matrix, if you don't have any insights into like what is the CPU usage, what is the memory usage, what is the network here usage, right? Then yeah, you're shooting in the blind. You wouldn't know when to auto scale. We are at the last slide. We are at the last slide, and then we can open up for questions. What is the future of auto scaling? How, and we have started seeing a lot of this. We have started adopting this. Right now, all the auto scaling is more reactive. Like, yes, the CPU utilization reached 50%. Now I'm going to start scaling. Instead of that, how do the all the infrastructure services have already started learning the patterns of their traffic? Like for example, A lot of services we have observed, they try to do their migrations on a Saturday, but we have to support it. So we know when the traffic will go up and at what time do we have to start it. Like we have to start auto scaling on our side as well, so to support them at best so that they observe less latency. For example, Hotstar, if you have your IPL matches going on in a certain season every year, then you an AI ML model will be able to help you to predict, right? For example, in case of festivities too, India has so many festivals coming: Holi, Diwali, Makar Sankrant, so many things. How do you try and make sure that your service, your all the instances are up and running, scaled before the traffic hits or before those festive season hits, right? Then comes the cost aware scaling. uh, like you don't want, for example, if I'm running a background job, right, probably parsing some Excel sheets, doing something, you don't want the best of the instances for this. I'm not going to schedule it on a GPU instance. A GPU instance comes up like so costly. Then how do we add those policies in for a for such processes that it makes sure that you just schedule a background job like this on a very minimal compute instance. Like you don't even need an EC2 perhaps for this. Something with very less compute, something with very less memory should suffice for this. Then comes the security and policy driven scaling. With more and more restrictions coming in from all the governments, right? Like for example, Israel government doesn't want their data to leave any data center outside their Israel data centers. Then we have to add policies according to that. We cannot let the data leave any of those data centers. We cannot auto scale their instance and bring an instance which is probably running on China data center. Then you would need to add those governance in, right? uh, then the last one is the self healing and self optimizing workloads. More now, as we have to not only consider demand, we have to also consider things like energy efficiency. We have to consider things like latency into picture when it comes to auto scaling. Especially when with ML inferencing, we are seeing that it is leaving such a huge environmental footprint, right? So then how do we take care of this? So keeping, how do we add all of these factors into our auto scaling and make it all the more efficient? We have already started seeing all of these patterns in all the major cloud providers. And yeah, let's see what comes up next. Yeah, I've just summarized all of this in one big slide. Don't want to bore you guys by adding more details on this. Yeah, that's all from me. And now I can take any questions if you guys have.
You told something around 2 years ago that from the dashboard directly, if some CPU is going up from the dashboard directly, there should be something like that that can directly auto scale that. I had seen some of the
Correct.
tools that are bringing up tools something around there are dashboards. There's some if you need some more info on some particular resource, let's say some particular cluster. So on a single
Mm.
click, they will just ask you need to set up you will increase this or not. So on a single click, they will increase their resources there. And I am seeing like some of the tools who are going on in this manner.
Yeah. Yeah. So, dashboard is a place for us to view those matrix,
Mm.
but on the pods itself, you will start seeing those events coming up or those events getting populated on. Based on that, only the autoscaler starts making those decisions.
Hmm.
Yeah. So yeah, Prometheus is one of the very famous. It's a very heavy one. It will
Hmm.
Prometheus itself will consume some CPU and some memory if it is running on your server. But yes, that is true. That is true.
I also work in one of the ICP startup. That's a middleware. We have like cousins. obsolete full stack platform. The SaaS
Wonderful.
platform, I
Right.
correlate with this because I do a lot of research and do a technical content sort of thing over here.
Right.
So
So
yeah,
what sort of tools do you guys use at middleware?
yeah. So we as in backend we have open telemetry, and on top of that we have made our own SaaS platform, just like you
Okay.
know Datadog or Neuralink something.
Correct.
Yeah. So
So
we have this.
open telemetry has been fairly new. I've seen a lot of adoption for open telemetry. How has your experience been with open telemetry?
So if you see, if anyone talks about logs, matrix traces in any industry, so open
Hmm.
telemetry is the godfather in that because open telemetry
Okay.
has impacted a lot of things and different products because it is the baseline of any operating line. It is the baseline.
Right. Right. Right.
Even though we are seeing promises and things, but
Hmm.
they are a smaller portion of that. Because open
Hmm.
telemetry has gone on a larger scale when it comes to logs, traces, matrices, all the things.
Right.
So
Yeah.
if you see what major company does is they just integrate open telemetry in that platform and they just use endpoints of some SaaS platform like ours, like middleware or Datadog or some platform.
Hmm.
So it won't be any vendor of they just need to replace the endpoints there.
Got it.
And
Got it. Yeah.
open telemetry also involved some of the new AI features. Let's say we also involve one of the new AI features called LLM observability. So whenever you are
Hmm.
hitting a single request to any LLM, you don't know
Hmm.
what is actually going on the back end of the LLM.
Right. Right.
Tools like OpenLit. If you search on OpenLit, it's also one of the CNCF back project. So OpenLit
Right.
and Facebook, there are some of the few projects of CNCF also. So they are helping to improve the efficiency of the results from the LLM. Because then will take all the traces of LLM request. It will show like from this point to this point and then this to this it has gone and how many tokens are consumed and everything around a single request and which model is used in LLM.
Got it. So does open telemetry support dashboards as well? Like,
Open
does it
telemetry,
have?
yeah. So open telemetry
It,
doesn't like have their own inbuilt dashboard. You can make custom sort of thing, but it fairly helps to have agents in different tech stack. Let's say Golang, Java, any application sort of thing, because it is
okay.
easily configurable in multi tech stack.
Okay. Okay.
So
Got it.
anything around authority space, open telemetry is there in the backend. Anyway.
Yes. Yeah, open telemetry has been used by a lot of even major cloud providers. It apart from Prometheus, yes, I've seen a lot of adoption for open telemetry, and I haven't got a chance to try it, but I would definitely try it out myself to see. And it's an open source one, right? You can
Yeah,
contribute to it if
it's
you.
it's one of the like third largest after Kubernetes,
Okay.
and as in from the contribution perspective, many people have
Okay.
contributed to open telemetry.
Got it. Got it. That sounds fantastic. All
The
right.
session was really good. Many people have learned about autoscaling, what are the different autoscaling,
I
HPA,
hope.
cluster. Yeah,
Yeah, I hope it was not a snooze fest. But if you have any questions, feel free to reach out to me. Or in general, if you have any questions about anything, how, yeah, I would be more than happy to help you guys. Yeah, I can leave my email address over here just in case if anyone wants to reach out to me for anything. Yep, or you can reach out to me on my personal address too. Alrighty. Thank you so much for having me. It was wonderful experience. I hope I was helpful a tad bit.
thank you for
Thank you
joining
so
us
much.
and joining on early morning here. And thank you
Sure.
everyone for joining in our third session. Hope to see you all continuing in our fourth session and fifth session to complete the whole KCLA bootcamp. And feel free to ask me or ask Payal any questions if you have. You can reach out on us with our LinkedIn or email anywhere.
Yeah, sure. Yeah, please feel free to reach out.
Yeah.
All right, guys.
Thank
It
you
was good
everyone.
having. Bye.